Hey folks, this is Mr. H coming back with your bus post lab. Just going to give you a couple quick hints, tips, tricks to make sure that you've completed your lab successfully and you're ready to hand it in. So this is going to be out of 24 points. All of the points are marked on each question, so double check that you've answered everything. So what materials did you bring out in the hallway to measure with today? What did you have to take out there with you to successfully complete the lab? So you went out in the hallway, you measured out 4 meters in length, marked the start and the end, let your buggy run, and recorded how much time it took your buggy to cover 4 meters. So the very first thing you're going to do is construct a data table. Look, I did not do this by hand. I used a nice straight edge here. These are nice straight lines. So grab a straight edge from the shoebox up front. You're going to go ahead and label your data table. So we have trial number in the left. We're going to have the distance we recorded for each trial in meters, and then the time for each trial in seconds. So I'm making this up. Do not use my data by any means, but I measured out 4 meters for my first trial, and I'm finding that my first trial was 9.07 seconds. So I'm going to use that to find the speed of my trial 1. You'll go ahead and record that for all 7 trials that you completed. Okay, in the next spot, we're going to go ahead and fill in the space provided here, the calculations for finding speed. So if you haven't figured it out already from the pre-lab questions, speed is distance per time. It's distance divided by time. This is also the slope we found from our DT graphs the other day. So speed is how far you go within a period of time. So for trial 1, my equation I'm going to use is S equals D over T. I'm going to substitute in my distance and time. My distance is 4 meters. My time was 9.07 seconds. Substitutions always include the units of what you subbed in. So if you were to write 4 and 9.07 without M and S, that's points off. Then you'll go ahead and throw 4 divided by 9.07 in your calculator, and S is equal to, at least for me, 0.44 meters per second, which of course is the unit for speed. It's how many meters you cover within a certain amount of time, this time being seconds. Okay, so then once you have your 7 speeds for your 7 buggies, they should be awfully close to one another. Probably not identical, but pretty darn close. You're going to take those speeds and you're going to convert them to kilometers per hour, which of course is the unit of speed that is used in Canada, Mexico, and all over the world. So we're going to use something called factor label. It's a unit conversion system. So if I wanted to convert 0.44 meters per 1 second, meters per second, into kilometers per hour, I would need to know how many kilometers there are per meter. And there are 1 kilometer for every 1,000 meters. We talked about that in the pre-lab. What I can do is I can set up this equality as a conversion in order to cancel meters, because meters over meters, right, meters in the top, meters in the bottom, will cancel. Okay, and then what happens is my only unit left on the top becomes the kilometer. So I'm already halfway there. I have kilometers on the top. So by taking 0.44 meters per second and multiplying it by 1 over 1,000, I'll have my kilometers per second, which is what I have here, right? 0.44 times 1 over 1,000 is 0.00044 kilometers per second. That's how far I go every second. I don't want to know kilometers per second. I want to know kilometers per hour. So I need to go ahead and convert my bottom here down to hours. So I do know from the pre-lab slide that there are 3,600 seconds in every hour. Again, I'm going to put my seconds on the top so that I have seconds over seconds. Seconds over seconds will cancel, and the only unit left on the bottom will be the hour, which is, of course, what I wanted. So mathematically, what I'm doing is 0.00044 times 3,600 divided by 1 times 1, which gets me a speed of 1.6 kilometers per hour. So you go ahead and perform that conversion on all your trials, change those all into kilometers per hour. They should be awfully close to one another. Once that's done, you're going to make another data table. This time, the data table is going to have all 7 of your trials with the speeds for all 7 in kilometers per hour. On the right-hand column, when we make data tables in this course, we put a sample calculation for how we found one of the pieces of information from our data table. Okay, so I show a sample calc of how I got 1.6 kilometers per hour. Just got to do it once in this case. Lastly, almost every lab we do in here will include some error analysis. Okay, so there are some things that went wrong in this lab that are built into how you measure or how you do the lab that cause error. Okay, you need to talk about what those errors were here specifically. Okay, things I will not accept is math errors, calculated wrong. Okay, those, if you knew you calculated wrong, you should go back and fix it. That's not an error. Okay, human error. Well, this is a lab run by a human, so yes, it is human error, but you need to be specific. What did you do wrong, or what was built into the lab that limited how successful this lab could be? That's what we're really looking for here, okay? So what could have gone wrong in this lab, or what with your measuring system was wrong with this lab that could cause you to find the incorrect speed? Okay, and then lastly, we're going to come back and we're going to answer those pre-lab questions again that were in the pre-lab video. Okay, answer those. Once you've completed all of those things that I've required of you and watched this video and you think it's good, go ahead and put your lab in the period 8 bin in the front of the room, and you can go ahead and work on reviewing for your quiz. Good luck, and we'll see you tomorrow.